As promised, here we are in part B. Let's get to it. Let's evaluate the limit by direct substitution to see if we get an answer. We're going to take the limit as x approaches 0 of this. But when we do this, let me get that there. That's going to give us square root of 5 minus square root of 5, and that's equal to 0. So we get a limit value of 0 in the numerator. When we do the denominator, we're going to take the limit as x approaches 0 of x, and that's going to produce a 0 in the denominator. So we have an indeterminate form. We'll get a limit value of 0 on top, get a limit value of 0 on the bottom. That's an indeterminate form. That doesn't mean it's a DNE. That means I got to try something else. So here we go. This new technique called rationalization. So I'm going to take the part that has the square root and I'm going to multiply by the conjugate of that. So remember that the conjugate is multiply. We're going to take the same first term, and the same last term, the second term, but instead of doing subtraction, we're going to do the opposite. We're going to add. And if I do it on top, I have to do it on the bottom. They have to keep it balanced so that the limit value does not change. Why do we multiply by the conjugate? Because when we do that and you multiply the numerator, when you multiply this times this, you're just going to get x plus 5. And when you multiply this times this, you're just going to get 5 that you're subtracting because minus square root of 5 times positive square root of 5 is minus 5. But you don't need to worry about the outer and the inner because they're exact opposites and they're going to cancel each other out. And then in the denominator, I still have an x times all of this red stuff, which I'm going to put in parentheses. Don't multiply this out, please. It's going to make it trickier. Well, in the numerator, look what happens. Plus 5 minus 5, that means I'm just left with x. In the denominator, I have x times the square root of x plus 5 plus square root of 5. And we're still taking the limit. As before, the x's are going to reduce out. And if I substitute a 0 into my variable of x, I'm going to get this, which is equal to 1 over 2 square root of 5. This is the limit value. We started with an indeterminate in blue. We substituted the value into the top. We got a 0 limit value. Substituted 0 at the bottom, got a 0 limit value. But there is a way to do it by doing this conjugation. They call it the rationalization method by multiplying by the conjugate. It's a little bit, but we're going to practice this in class. There are other ways to simplify. There are other techniques for simplification. I know there's a complex fraction technique, but mostly on the AP exam, they focus on factoring and on rationalization. And later, when we talk about the derivative and how to find derivatives quickly, we'll be able to learn L'Hopital's rule, and L'Hopital's rule or L'Hopital's theorem is going to make limits go by a lot faster. So for now, we're learning these two techniques, factoring and rationalization, and that's it before we move on to the next part.